Hi everyone, and welcome back to Educator.com. I'm Dan Fullerton, and now we're going to continue our work through the 1998 AP Physics B examination by doing free response questions 3 and 4. So let's dive right in with number 3. And as we start number 3, one thing to note, the AP curriculum has changed a little bit since they released this practice exam. So not all of this question has items that are covered in the curriculum currently, and I'll point those out when we get to them. So to begin with, we've got this very interesting apparatus that's designed to explore the conversion of mechanical energy into thermal energy. And question A is asking us what happens if you close the lower valve, flip this upside down so you've got all these beads on top. What amount of work must you do in order to do that? And that's a pretty fair question for them to ask us. So work, recall, is force times R times the cosine theta. Or in this case, it's a conservative force, so we really don't even care about that cosine theta. It's just going to be Fr, which is going to be capital mg, the force required to overcome gravity, times h. Or you could have done that by conservation of energy, realizing that you're going from what we're calling 0 down here all the way to gravitational potential energy, mgh. So there's our answer to part A. Now in part B, it says we're going to open the valve, let the leads tumble down into the hollow sphere, and as that gravitational potential energy gets converted into thermal energy, what's the temperature increase of the lead? Now, this would not be on the current test, no longer asked, but we'll do it anyhow since we're here for those of you who might have an interest. Well, in this case, that energy that we had, mgh, is going to be equal to the mass times the specific heat times the change in temperature. Therefore, delta T will be mgh over mc saying that backwards. D has the same voltage as B and C, but because there's only one of these, it's going to have lower resistance, so it's going to have more current flow. So D must come next. It has the same V, same potential drop, as the BC branch, but lower resistance, so more current, therefore more power. And finally, B and C have the same current and the same voltage drop across them, so they would come last. B and C, same current, same voltage drop, same power, so equal brightness. Great. Moving on to part C, we're going to remove bulb D from the socket and describe what changes happen to bulb A. Well, let's redraw that where we pulled D out of here. So now we're going to have our voltage source, and our circuit's going to have B, C, and A. A simple series circuit. Well, what happens here is our total current, well, our total R is going to increase because we don't have this parallel section. So if our total current goes up, that means that the current through A, which was the total current, must go down. Our power is therefore going down. Power equals I squared R. So our power through A is going down. So the brightness of A must decrease. And in C2, we're going to describe what happens to the brightness of bulb B when this happens. So bulb B, well, let me label this C1 and C2. What's going to happen to bulb B? Well, across bulb B, we're going to have the potential drop go up. So the voltage drop across B is increasing because we don't have this parallel element anymore. So the voltage is going up, and power equals V squared over R. So that's going to be a very strong term. We're going to see the power through B go up. Therefore, B is going to get brighter. And that will do it for questions 3 and 4 on this practice exam. Please join us next time. We'll go through free response questions 5 and 6. Thanks, everyone. Make it a great day.